Okay, so today we're going to be looking at powers and roots of negative numbers and some things that happen when we're dealing with a negative base and different exponents. First off, if you look at what I've already written in here, it says, so we have different powers all for this base of negative 2. Now what this first sentence says is it says integer powers of negative numbers alternate between positive and negative numbers. This is what they're describing over here. Negative 2 to the first power is a negative 2. Negative 2 squared is a positive 4. Negative 2 cubed is a negative 8, and so on. Now a pattern exists there that's important to recognize. Notice that when we have an odd exponent, 1, 3, 5, and so on, of a negative base, our answer is going to be negative. Where if I have an even exponent, 2, 4, 6, and so on, of a negative base, my answer is always going to be positive. That's what I've highlighted here. So what we're going to fill in here is that even exponents produce positive numbers, while odd exponents produce negative numbers. Now integer powers of negative numbers do satisfy the order of operations. For example, now this is really important, and I've talked about this earlier on in the year, how important it is when we're dealing with negative numbers to include parentheses. Because negative 6 to the fourth power is actually going to be negative 1,296. Now you might say, well, wait a minute. 4 is an even exponent. We just said that even exponents produce positive numbers. So how can negative 6 to the fourth power be negative 1,296? Well, the reason for that is because the power is calculated before taking the opposite. Meaning, this exponent, remember order of operations. What's our first order of operations? Take care of exponents. Well, technically parentheses, but then second would be exponents. Since there's no parentheses here, we would take 6 to the fourth power, which is 1,296, and then apply the negative. Where, look at this next sentence. It says negative 6 in parentheses to the fourth power. Well, that's going to be 1,296 positive, because we would take everything in parentheses and raise it to the fourth power. And a negative raised to the fourth power is going to be positive. So that tells us that negative 6 to the fourth power without parentheses is not the same as negative 6 in parentheses being raised to the fourth power. Okay, let's look at some other examples here. Now, first off, if you printed out my notes, this is supposed to be a negative 2 there. So if we have, they say write without exponents. I have negative 3 to the fifth power times negative 3 to the negative second power. Well, if you notice, the bases are the same. So remember what we talked about in previous chapters, that when the bases are the same and we're multiplying, we add the exponents. So this is going to be the same as negative 3, 5 plus negative 2 is 3, and negative 3 cubed, remember it's a negative number being raised to an odd exponent, so our answer is going to be a negative, and 3 cubed is 27. Why don't you try the next one on your own? So pause the video and hit play when you're ready. Okay, so again, the bases are the same, so that tells me that we can add the exponents. So it's going to be negative 5. Again, make sure you put that in parentheses. And by the way, too, you should be doing these without a calculator, because on the test, many of these types of problems will be done without a calculator, so make sure you're getting that practice in. So negative 4 plus 7, we add the exponents, that's going to be cubed. And so we have a negative number being raised to an odd exponent, so my answer should be negative. And 5 cubed, this is something we should memorize, 5 cubed is 125. Okay, so let's look at this next section here. So in this course we have seen that powers and roots of negative numbers do not have the same properties that powers and roots of positive numbers do. Here's some of the properties that are different. So when x is positive, so when I have the square root of a positive number, my answer is going to be a real number. But when I have a square root of a negative number, it's an even root of a negative number, my answer is going to be a pure imaginary number. And that's where we have to use the letter I. Now, if both x and y are negative, the square root of x times the square root of y does not equal x times y. And here's why that is. Let's look at an example. Let's say if I have the square root of negative 3 times the square root of negative 2. I want to see, does that equal the same as the square root of negative 3 times negative 2? I want to see, are these two the same value? Well, remember when we talked about square roots of negative numbers, we said that before we do any multiplying, we can't do anything with the square root of a negative number. We have to take out an I. So this is going to be the same as I squared of 3 times I squared root of 2. And I times I is a negative 1. So this would be a negative. And 3 times 2 is 6, so I have a negative square root of 6. Let's look on the other side. Negative 3 times negative 2 is a positive 6. So that means here I would just have the square root of 6. And obviously, negative square root of 6 is not the same as a square root of 6. So we've just proven this second point. Let's look at the third one. If x is negative, then x to the nth power does not equal the square root of x to the 2n power. Here's what they mean by that. Let's say if I have negative 2 and I'm cubing it. Well, that is not the same as if I took negative 2 to the 6th power. Here's why. Negative 2 cubed, we know that's going to be a negative number. Since it's a negative number being raised to an odd exponent, my answer is going to be negative, so that gives me negative 8. Now over here, we have the square root of negative 2 to the 6th power. Now you might say, well, wait a minute, the square root, if I take 6 divided by 2 is 3, so isn't this the same as negative 2 cubed? Well, it's not. Here's why. We have to take negative 2 to the 6th power. That is going to be a positive answer. 2 to the 6th power is going to be 64. And the square root of 64 is a positive 8. So obviously negative 8 does not equal positive 8. So those are just some different properties that are true about when we're dealing with negative bases and exponents there. Okay, so let's look at this next example. So this box is saying when x is negative and n is an odd integer greater than 2, the nth root of x stands for the real nth root of x. Here's what they mean by that. Let's look at some examples. Let's say if I have negative 5 cubed. We know my answer is going to be negative 125. So in other words, you can write the cube root as negative 125 equals negative 5. So what this essentially is talking about, what this box is saying, to put this in better terms, is that the odd root of a negative number is always negative. Now the key here is that we're dealing with the odd roots. So if I have, that's what this is saying, if we have a root that's an odd integer, an odd number greater than 2. So if I have an odd root of a negative number, we're always going to end up with a negative answer. We're never going to have to deal with imaginary numbers. So here, if you can't read this, it says we have the cubed root of negative 64. This is an odd root of a negative number, so my answer is going to be negative. And the cubed root of 64 is 4, because 4 times 4 times 4 is 64. So in other words, whenever we're dealing with the cubed root of a negative number, we can always right away take out a negative, because if we can't do anything else, we at least know that your answer is going to be negative. So why don't you guys go ahead and try the next one. Pause the video and play it when you're ready. Okay, so with this one, again, we have an odd root. It's the fifth root of negative 32. So since it's an odd root of a negative number, I know I can take out a negative. And the fifth root of 32. Well, if you don't know what that is, you'd have to do a factor tree. Otherwise, you should be getting the hang of that. Well, let's just do a factor tree just to make this, so make sure you understand this. 32 breaks down to be 4 times 8. 4 breaks down to be 2 times 2. Those are both prime. And we know that 8 breaks down to be 3 2's being multiplied by each other. So I have a total of 5 2's, so my answer is going to be negative 2, because we're looking for the fifth root. So for 5 of the same number, I get to take 1 out. So hopefully that makes sense. So again, the main point here is that when you're dealing with odd roots of negative numbers, your answer is always going to be negative. Now what this box is saying is essentially that when we have the even root of a negative number, your answer is always going to be an imaginary number. Okay, so let's look at these examples to end this lesson. Here we have the fifth root of negative 640. Just like some of the problems we're doing in the previous lesson, some of these are not going to work out evenly. Now again, right away I have the odd root of a negative number, so I know that my answer is going to be a negative number. Now the fifth root is 640. I don't know what that is, so I'm going to take and do a factor tree here. Now I know 10 times 64 will give me 640. 10 breaks down to be 5 times 2. 64 breaks down to be 8 times 8, which we know that each of those are 2 times 2 times 2. So for every 5 of the same number, I get to take 1 out. So that means that with these 5 2's here, I get to take out a 2. Oops. But I'm left with 5 times 2 times 2 under the radical. So 5 times 2 is 10, times 2 is 20. So my answer is negative 2 times the fifth root of 20. Now your answer should never leave a negative under the radical. So if you still had a negative underneath there, you did something wrong. So that's why one of the first things I did is I wrote the negative down, so that way I wouldn't forget about it, and also that I remember to leave it outside of the radical. So why don't you guys try this last one, and we'll check your answer in a minute. Okay, so let's check to see how you got. Let's see how you did. So again, it's going to be a negative answer. And when I take 1,250 into a factor tree, I get 10 and 125. 10 is 2 times 5. 125 is 5 times 25, which is 5 times 5. So for every 3 of the same number, I get to take 1 out. So I have 3 5's there. So I'm going to take out a 5. I'm left with 2 times 5 under the radical. And that's it. So hopefully you have a better understanding of how to do this, and you'll be able to do just fine on your homework. Good luck.